Welcome to Study Loop.
So we're told that there's a massive object at the center of the galaxy, and there's a ring of material orbiting it. And so in part A, we want to figure out what the mass of that object being orbited is. So because it's a ring of material that's orbiting it, we can assume that this is a circular orbit. So that means for a circular orbit, we know the velocity of the orbiting object will be the gravitational constant times the mass of the object we're interested in here, divided by the orbital radius. So we want to solve this for the mass of the object, since that's what we're trying to find. So we square both sides and do a little algebra, and we should get that that mass is equal to v squared times the radius over g. And so we pretty much have everything we need now. So we know that the velocity is 200 kilometers per second. So the main thing we have to do is just be careful we convert all our units correctly. So 200 kilometers a second should be 200 and then 3 more zeros to get meters per second. So v squared, they give us the radius then. Well, they give us the diameter, so we need to make sure that we divide by 2 to get the radius. And so then in the appendix, you can look up the length of a light year. So I'll write this as d divided by 2 for the value that they give us. And then our gravitational constant, 6.67 times 10 to the minus 11th. And so when we do that, and we're careful with all of our units, we should get the mass is 4.3 times 10 to the 37th kilograms. And then they ask us to compare this to the mass of the sun, or give the answer in solar masses. So again, looking that up in the appendix, we should find it's 2.1 times 10 to the 7th solar masses. Part B then asks us, is it possible this object is a star, given that we don't think that stars can exist with about more than 50 solar masses? So given that, no, it doesn't look like this can be a star. It has a mass of 21 million times that of the sun. So that seems like a pretty clear no. And C, we want to know if it is a black hole, what would its Schwarzschild radius be? So for that, then, we just say that the Schwarzschild radius is 2 times g times the mass of the object over the speed of light squared. And so that's, again, pretty easy to evaluate. We have all those quantities now. So you want to make sure we're using the mass in kilograms, not solar masses. And if we do that, we should get that is 6.32 times 10 to the 10th meters. And part D then asks us, is it possible for this to fit inside the Earth's orbit? So is it less than the distance between the sun and the Earth? So we look up that value in the appendix, and yes, this value is less. So that means that this supermassive object could fit inside the Earth's orbit.